Okay, the next part of this is the more complex of the trig identities, and we're going to talk about some Pythagorean identities. And once again, these are things that need to be memorized, committed to memory, but we're going to have some exposure to them that's going to allow us to make sense of what they actually mean instead of just rote memorizing. So let's investigate. First of all, we're starting from the premise that x squared plus y squared is equal to r squared, which is what we talked about in terms of both the Pythagorean theorem, which is where we get the Pythagorean identities, and the concept of the graph of a circle. And so when we investigate this, if we have x squared plus y squared is equal to r squared, we're going to do a little bit of manipulation of this. And this is what Pythagorean identities and trig identities in general are about, is making something out of something else. And so if I'm going to solve for this, look at what I'm going to do. I'm going to divide both sides by r squared. Well, what I'm going to end up with is something, an expression that's equal to 1. Well, then, look what I've got. I've got x squared over r squared, but really, that looks like this. Okay, I'm going to erase this and move it down just a little bit. I'm going to write it in a different color. Is equal to 1. Well, look at what happens. I've got x over r squared plus y over r squared. Okay? If you'll notice, look at what happens. X over r, well, that's really cosine squared theta plus sine squared theta is equal to 1. This is one of our main trig identities right here. This one is awesome. It's going to help us out of a lot of pinches when we're talking about proving identities, okay? And so that's what we've got. That's one of our main ones. So be sure you write that one down. That's one of our Pythagorean identities, okay? Now, let's look at what we've actually got here. If we take this identity, and once again, we're going to be manipulating variables to get what we want, cosine squared theta plus sine squared theta is equal to 1. What if we tried to make just cosine? So right now we've got cosine squared plus sine squared is equal to 1. We're going to try to make just cosine. And so we are going to solve for cosine. So I'm going to subtract sine squared from both sides because really these are just algebra manipulations that we're doing here. And so this goes away. What we have here is cosine squared theta is equal to 1 minus sine squared theta. Okay? I don't want cosine squared theta. I want something a little bit more usable. So what I'm going to do is I'm going to take the square root of this side and the square root of this side in order to give me cosine squared theta, or cosine theta is equal to plus or minus, because remember, anytime I've got a square root, the negative squared is the same as the positive squared. So I've got the square root of 1 minus sine squared theta. Okay? You see how that works? And so this is another one of our trig identities. Okay? And I could do the same for sine squared, but I would just flip-flop the roles. So I'm going to have sine squared, or sine theta is equal to plus or minus the square root of 1 minus cosine squared theta. Remember, I can't break up that part inside the square root because my identities and my rules don't allow it. Okay, so here's 3 of these that I need to know. 1, 2, 3. Got to have those. Got to know those. Okay? Now, let's take a look at one other one. And I'm putting up a blank slide here because I want to be able to refer back to that last one. We had cosine squared plus theta plus sine squared theta was equal to 1. Now, here again is a thing where I'm going to manipulate these variables. Look at what I'm going to do here. I'm going to divide everything by cosine squared theta. Okay? Look at what happens. Cosine squared theta over cosine squared theta. Because remember, I can break up the numerator, but I can't break up the denominator. Sine squared theta over cosine squared theta is equal to 1 over cosine squared theta. Look at what this actually means. This is beautiful because cosine squared over cosine squared is 1. Plus, now, recall, sine over cosine was going to give me tangent. So this is really going to be tangent squared theta is equal to, remember 1 over cosine? Secant secant squared theta. Here's another Pythagorean identity. Coming out of that whole concept that x squared plus y squared is equal to r squared. Okay? If I did the same thing, if I took my cosine squared plus sine squared is equal to 1, and instead I divided both sides by sine squared, look at what I'm going to get. Cosine squared plus a lot of writing. It's going to be worth it though, I assure you. Okay, look at what happens. A lot of things start disappearing here. I've got cosine. But remember, cosine over sine was cotangent. So I've got cotangent squared theta plus 1 is equal to cosecant squared theta. You see where I'm getting this? Okay, so this is the last of our fundamental trig identities. We're deriving these by manipulation of the sides of the equations. Okay, I haven't done anything that we haven't done 10,000 times in algebra. I've simply divided both sides by the same thing, and I'm reducing. Okay, so those are our basic trig identities. Let's use a couple of examples to try to figure out how this actually works and start working with it on a more realistic basis with some numbers. Sine theta is equal to 3/5, and theta terminates in quadrant 2. Okay, so think about the implications of that. So we are going to try to find cosine theta and tangent theta. How are we going to go about this? Well, let's look. You can't stress enough when teaching this class how important it is to know these identities. Because if I'm trying to find cosine, let's just use the actual formula. So cosine theta is plus or minus the square root of 1 minus sine squared theta. Look at what happens. All I'm doing, guys, is substituting. That's all I'm doing. And I'm using an identity to substitute. So I took the formula for cosine, the identity for cosine, and I'm saying it's plus or minus the square root of 1 minus. And what was sine theta? Sine theta was 3/5. So I'm going to do 3/5 squared because it's sine squared theta. Now, still carrying down my plus or minus. I've got square root of 1 minus 9 over 25. Watch what happens. You're going to kick yourself when you see what happens. 16 over 25 is left. Plus or minus the square root of 16 over 25. Now, remember, this is really equal to plus or minus the square root of 16 over the square root of 25. Guys, look at what happens. It's a beautiful thing. Okay? So I have now equal to plus or minus 4 over 5. How do I decide which one it is? If it's in quadrant 2, look at my x. Okay? Here's my quadrants. So in this one, x is negative. Okay? And cosine, x over r. So it must be the negative option. So we're talking this is equal to negative 4/5. Okay? See how that works? Right there. I'm using my identities. Okay? So if tangent is equal to, I'm moving stuff around. Tangent is equal to sine theta over cosine theta, guys. Once again, the definition. This is equal to tangent, and this is what I want to find. Okay? Tangent is sine over cosine. I have the sine. It's 3/5. I have the cosine. It's negative 4/5. I'm going to take 3/5, multiply by the reciprocal, cancel it out. Done. I'm using definitions here, guys. That's all I'm doing. I'm not doing anything special. I'm using the definition and substituting. It's all about patterns. Okay, so you're seeing how I'm doing this. At first, I used one of the identities to find one of the ratios, and then I just used the definition of another ratio to find it and substitute in. That's all it is. We're going to do one more example here. Try to see if you can do this one on your own. Use the same sort of use the same sort of strategy, and I'm going to go through it right after you pause. So go ahead and pause it if you'd like, and we're going to go through it. Okay, now we're going to find the trig ratios. That means all 6, but we're not afraid because we know what we're doing. Okay, so here's what we've got. Sine theta is equal to plus or minus square root of 1 minus cosine squared theta. Why did I choose this one? I don't know. I know that I need all 6. I have cosine. Okay, so I've got one here. I'm going to find my second one here. Okay, and we're going to go from there. I remember, of course, that this is x divided by r. Okay, and sine is going to be y divided by r. So here, let's get a little bit in here. So I'm going to have 1 minus, and then I'm going to substitute 1/2 for my cosine, because that's what it told us. It told us it was 1/2. 1/2 squared is going to be 1 over 4. That's not a 4. That's a 4. Okay. And so we're going to have equal to plus or minus the square root of 3 over 4. Watch what happens. I know that this is equal to square root of 3 over square root of 4. Plus or minus still. Okay? Equal to square root of 3 over 2. Now, look at this. Look at how beautiful this is. Cosine theta is equal to x over r is equal to 1 over 2. So, for those of you keeping track at home, x is equal to 1. Y, we don't have. R, we have. But look at what we got now, guys. Sine theta is equal to square root of 3 over 2, which is also equal to x y over r. So now, do we have y? Yes, we do. We've got square root of 3. Why does this help me? Because now, not only do I have 1, my sine, 2, my cosine, now I can just fill in the rest of the bubbles. Okay? So cosine theta is equal to 1/2. There's one thing that we're neglecting to talk about here. Is it positive or negative? We're in quadrant 4. Okay? Now, in quadrant 4, is y positive or negative? Okay? So when I'm thinking about sine, I'm thinking about my sine theta. In the fourth quadrant, y is negative. Okay? So if I'm dealing with a y here, I know this has got to be negative and this has got to be negative because the sine is involving y, which is negative in the fourth quadrant. So my sine is going to be negative 3, square root of 3 over 2. It's going to be negative 3 up here. All right? So then my tangent, theta, what have I got here? I've got sine over cosine, and so I'm going to have negative square root of 3 over 2 over 1 over 2. So that's going to give me square root of 3, the negative 1. Okay? And then I'm just flipping. Secant theta is equal to 2. Cosecant theta is equal to negative 2 over the square root of 3. And cotangent theta is equal to, now careful here, I'm going to have 1 over square root of 3, and that's going to be negative. Okay? Look what I've got. 1, 2, 3, 4, 5, 6. I've got all 6 of them right there, guys. I'm just using the definitions to find one of them and then using what I already know to find the rest of them. Okay? That's the basics of trig identities. We'll look forward to seeing you next time. Thanks for watching.